We know it's cosine of A.
Example 1, or example 101. As we talk about this, the idea is the limit of sine x over x. Now, this is for small values of x, okay? And, I mean, there's a couple of different ways we could look at this, and we'll talk about, in general, what you need to know walking out of here. But, example 1, what are your thoughts of how we could do that limit? What are our options? Okay, L'Hopital, because you've already tried putting in 0, and the sine of 0 is 0 over 0. So, one option is L'Hopital's. So, if we do L'Hopital's, this problem becomes the limit as x approaches 0 of derivative of sine x is cosine x. The derivative of x is 1. And this is, by the way, because it was 0 over 0, right? Now what happens? The cosine of 0 is 1, and thus 1 over 1 is 1. Okay. What else can we confirm that, by the way? Did we grab it? Okay. And this is a graph. Was it this year in calc or was it in pre-calc? We've talked about this.
I think you've seen it.
Yeah, it seems familiar.
Got one. We had that lesson with like those 6 graphs. Was that one of them?
I think it was.
Yeah, because if you approach it from the other way, it's not existent, right? Or is it
No.
always that?
No, you're thinking of a different graph there.
Wonder.
I did mine on a Z trig, instead of the Z standard or whatever, Z square or whatever, Z standard, I guess. Notice, basically it oscillates up, down, and then as it approaches 0, it goes up to 1 for both sides. If you look on a regular standard graph, it's hard to see there, but it's just oscillating up and down real lightly. Okay, it doesn't go all the way up, but it does go up at 1. Okay? So, what you need to know. The limit as x approaches 0 of sine x is equal to 1. Now, let me make sure I write this. What we can walk out of here today. The limit as some variable approaches 0 of sine of said variable divided by said variable will always equal 1. And I guess I probably should have x in here for x approaches 0. Keep in mind it doesn't have to be x though, does it? So I'd probably, instead of having the parentheses there, I'm trying to think the best way to do this. The limit as x approaches 0 or whatever variable. But the sine of said variable over the same said variable is going to equal 1. Okay? So, and there's some variations we can look at here, which is what we're going to look at. For instance, if this said sine of 7x over 7x, the limit as x approaches 0 of sine of 7x over 7x is going to be 1. If we said 99x in both places, it's going to be 1. Okay? It's the best way to explain it. Now, look at example 2. I mean, yes, technically we can use L'Hopital's. Yes, technically we could look at a graph. But this is one where it's, again, good to be familiar with, okay, sine of something over x. What's that work with? And what do you notice here?
It's sine of 4x over x.
Okay, sine of 4x over x. Same basic thing, other than there is a 4 right there. So, no, you can't technically pull that 4 out, but that's kind of what we're thinking here. If you pull that 4 out, it's the limit as x approaches 0 of sine x over x, and then times 4. And so because of this 4 right here, yes, this limit does equal 4. Now, the proof. How can I prove this? L'Hopital's. Okay. A graph, yes, but you do have to have the calculator for that, right? Yes. So the graph is always the other option. So just so you guys make sure we understand, if we L'Hopital it, it's still 0 over 0, isn't it? So it becomes the limit as x approaches 0. What's the derivative of sine of 4x?
4 cosine of 4x.
Yeah, derivative of sine of 4x is cosine of 4x times the derivative of 4x, which is 4. So 4 cosine 4x all over the derivative of x is 1. When you put in 0, it becomes 4 times, well, the cosine of 0 again is 1 over 1. Are you a believer?
Yes.
Equals 4, right? So this is, it's not that we have to do this L'Hopital stuff. This is just me trying to show you so that you believe me. Okay? So I'm going to ask the same thing on example 3, if you can come up with what you think the answer might be. I'm debating which way I want to do this here, but thoughts?
1 over 47.
Mm-hmm. Because, and look at it this way, I'm not going to do L'Hopital this time unless you really want me to. But let's play the what if game. What if this was the limit of sine of 47x over x? What if it was that? It'd be 47, right? So the idea is if that's upside down, then it's going to be 1 over 47. Okay? L'Hopital's or a graph could prove that to you. Okay, so sine x is just a good one to know. Limit as x approaches 0 of sine x over x. L'Hopital's is there as your proof, but be familiar with that. Okay? One other item to look at that I already heard you guys complaining about, right? Proof of derivative of sine x. To prove the derivative of sine x is cosine x, we only have to prove that the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. So that's our job. We want to take the limit as x approaches 0 of 1 minus cosine x over x. And our goal, when we get to the end, is that it equals 0. That's my goal, right? That's how a proof works. You take one side, usually we say the left side, but regardless, you take one side, and your goal is to manipulate it with appropriate mathematical steps and get it to land there.
She makes up space.
Because there's steps to do.
I know, but that makes me think there's a lot of steps.
Just thinking, yeah, I mean, if you L'Hopital it equals 0, settle for.
L'Hopital is not really an official method to use in a proof, though. Okay. So, I get it. I get your, oh, hey, L'Hopital will, get us right there. However, we're not going to use L'Hopital.
We're gonna have to use like identity to correct.
Well, and here's the deal, guys. We're working with the idea of the limit of sine x over x today, yes? So we're going to end up with a sine x over x in there eventually.
Yeah.
Now, our first step, our starter step, is to get out of that form right there. We're going to start by multiplying by the conjugate of the numerator. Now, if we multiply the conjugate of the numerator by the numerator, we have to do the same to the denominator, yes? That's just typical math 101. And I can multiply by 1 plus cosine x over 1 plus cosine x, because really all I'm doing to this fraction or limit is multiplying by 1. So I'm now going to have, notice I'm going to rewrite limit every time, because that's officially what I should do. On top, what is 1 minus cosine x times 1 plus cosine x?
Cosine squared x plus 1.
Not quite.
1 minus cosine x or square x.
1 minus cosine squared x.
Oh.
Because when you FOIL 1 times 1, outer and inner cancel, and it's a minus cosine squared x, which I'm not against switching the order, but you didn't have a negative in there, I don't think. So, denominator, I'm just going to leave it as x times 1 plus cosine x. Okay, so speaking of identities, that numerator is the Pythagorean identity, right? Sine squared plus cosine squared equals 1. So 1 minus cosine squared can be replaced with sine squared. So limit as x approaches 0 of sine squared x over x times 1 plus cosine x. This proof is on the day we're learning about sine x over x, isn't it? I hinted that we are going to talk about a sine x over x. Do you see a sine x over x? We take that fraction and split it up.
Break it up,
Yeah.
sine x over x times sine x over 1 plus cosine x.
Okay, let's break it up like that. So we're going to take that one fraction and we're going to break it up into basically two fractions. A sine x over x times a sine x over 1 plus cosine x. Officially, if I'm trying to be official and use all the, official notation, the limit of a product is equivalent to the product of two limits. Which what I'm saying there is that two fractions being multiplied within a limit can be rewritten as two limits. So this is the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of sine x over 1 plus cosine x. So does that make sense when I say the limit of a product is equal to the product of two limits? It's always confusing to say, but this is the limit of a product, but it's equivalent to the product of limits. Okay, so that's one of our limit rules that we're allowed to use. What do we know right here?
Well, I know that that's one, the other one is zero.
Okay. So we know this one is 1. We don't have to use L'Hopital's or anything because this is, this is the limit that you're expect, just it's a good one to know. On this next one, we can do it without L'Hopital's, right? You can plug the value in, and you have 0 over 1 plus 1, I guess. But that is 1 times, and 0 over 1 plus 1 is 0. And 1 times 0 is 0. And we proved it without L'Hopital's. Okay? We proved it without L'Hopital's.
Good job, Sam.
Look at us doing magic stuff. That's what I have now.
Okay, I have
How was your last
19
in school lesson?
becomes number 9
It was nice. I enjoyed it.
from 93. And then I have Ethan's favorite, Skip, 7 and 8. So 19 becomes 9 from 93, and Skip 7 and 8.
We got one day.